show you the process I went through. Now, the process that I used, or I use now, as of this project, is influenced by Tom Lipton. Tom Lipton has a YouTube channel, Ox Tool, and in his book, and actually wasn't his book, it was his video, his Four-Jaw Challenge video where he mocked up something that's never existed before. And he showed us, this is in 2016, the second year I think they had the challenge. But he showed us how he mocked it up, and he's a wise, he's a seasoned man, and he's got some wisdom, and I'm glad he's willing to share it with us, because he made my job a lot easier by giving me a thought process that I can build upon. Okay, so, and if metalworking, doing it better, machining, welding, fabricating, Tom has a book out. Tom has 2 books out, but this is the newer one. His old one appears to still be in print because I inadvertently bought both books. But Tom has his original book and then this book, which includes that, and then some more sage wisdom. So, not a bad purchase, guys. So my project had to do with mounting a GoPro camera on a magnetic base. So the magnetic base is this blue thing here. So we use these a lot in machining. It has an on-off switch here for the magnet, which will stick to the ferrous metals. And it has articulation with the arm. This one's hydraulic. With this one knob, loosens all the joints, and you can move it and then lock it back up. So we use these a lot for holding or measuring equipment, our lie detectors. So I needed to fit this hole on the end right here. This is a 3/8 inch hole, or .375. We will need that later. Okay, so I'm going to put this back in the holder. So this screws into the bottom of the camera. It's a 1/4-20 thread on the end of there. Pretty standard thread, pretty standard non-metric thread. And then the other end of this guy has my 3/8 inch arbor. The overall length of this thing is about hand width, about around 3 inches. So I figured you could use it as a handle also, if you need to. Okay, put this back to the bottom of the camera and mount it on the magnetic base. So I needed a way to put this GoPro on this magnetic base you're hanging from right now. So here's the process I went through. First thing I did is I went and looked at their design. Somebody has already done some of this work. Do it easy, as simple as possible, and as easy as you possibly can. So I went and looked at their stuff, and their design was the opposite, or the negative, of this design here. So on this guy, we've got 2 flanges with a gap in the middle and a hole going through it. So what they've done here is they've used this hole as a pivot point to pivot the camera. You can see me there. So this pivots the camera. So that's why that's there. So their negative adapter that fit this had a flange on the outside, like here, had a flange in the middle that went into this guy, and then it had this outside that went out here. So they put a piece of metal in contact with this side, both 2 of the middle sides and this far side. And it's a really good design. It gives them 1, 2, 3, 4 friction points for securing this camera. So I like that they do that. So that's what I wanted to do. I started out wanting to do that. So I started out thinking this way, and thinking about how I was going to make this part. And that's the beauty of being a machinist and not an engineer, is when I put it down to paper, I'm thinking about how to make it. I don't want to design something that is impossible to make, or difficult, if I can get around it. So I started thinking about how I was going to cut out these two areas to fit these two flanges. And I'm thinking, okay, I can put an end mill in there if that opening is small enough. And that opening is going to fit one of these guys. So let's see what you are. Yeah, so you're about, shoot, 120 thou is the width of this gap right here. So do I have a cutter that's 0.12? Well, I got 125. I've got 1/8 inch. Let's measure that again. It's still a little under 1/8. Okay. Jeez. Not a good blade. This is not the best tool for doing this, by the way. Okay. So it's a ways under 1/8 inch. An 1/8 is 125. So yeah, so we're 1/10 thou off. Okay. That's not too bad. So I could come through and make these with an 1/8 inch end mill. Coming down from the top, taking a pass, plunge a little deeper, take a pass, and that way. Which is a more laborious setup. Well, shoot, I don't know. Slitting saw takes a while to get set up too. The other option was come in here and set this part on the side and take a slitting saw. Now I need to find out if I have slitting saws wide enough to, or thin enough to cut that small of a curve. Lo and behold, I'm a half day into the what ifs when some of Tom's logic dawned on me. And Tom, in his logic, he states that when you're just at the early stages of getting these things out of your brain and into the real world, start with the simplest translation as possible. And that's where this piece of paper comes in. Ultimately, I intend on going into a CAD program and creating this part in the digital world, and then so modeling it up, making a print, and then making my part to that print. But what Tom says is this: you're not ready to go CAD yet. Start with generalizations. Get in the ballpark. The CAD system gets you asking too many detailed questions way too early in the developmental stage. So, taking Tom's wisdom and hopefully remembering it from henceforth, I broke out a legal pad and started scratching. So, the first thing that went in the chopping block is copying exactly what GoPro does. This slitting, making this area here, was just going to be ridiculous for a one-off. So I nixed that idea. I said, okay, fine. So we just have this completely open groove in there in the part that this part fits down into. All right. Now, the reason they have another piece between these two is because when we put a bolt through this axis and tighten, these two flanges come together. And if there's nothing in the middle, these two are going to bend. They can break, but they'll definitely grip incorrectly. They won't grip along the whole surface. They'll grip better on top and on the bottom. Anyhow, so I couldn't leave their idea completely. So what I did is I left out the middle finger, and I just decided to go with a washer. Just cut a washer on the lathe to the width I want and put it in there to take up that gap. So boom, that's quick and easy, quick lathe job. So that's how I got the basic design for how this guy was going to work. Now, or at least for how the interface was going to work. Now, some of the other questions is, okay, what size overall does this part need to be? And when you start talking about limitations, go for the minimum. What is the least amount I can do and use to make this part? So, what I did here is I wanted to decide on a width. I needed some stock on this side out here, and I needed some stock out here. And what can that width be? I'm really comfortable with 100 thou of material, 0.100. That I just mess with round numbers of just to get them in my head and start trying them. So there's the opening on the calipers right there. So about the width of one of these legs. I'm going to put that side on the other side. All right. So since I've already measured from side to side, and come up with about 375, 376. Okay, now that's the actual measurement of the part. Now, I don't want to make my part exactly the same dimension. I need some more room in there. So I rounded up to 0.380. So let's take that data I have, 0.38. I'm going to put 100th thou on either side, plus 0.1 equals plus 0.1, 1 for each side. All right, 5.8. I come up with 5.8. Now there's some numbers that tickle your brain, and those numbers are cardinal numbers. They're the easy numbers. I don't like real small numbers. I like big fat numbers that I can use fat crayons with. Now, when I see 0.58, I start trying to get that close to a number I'm familiar with, and that is very close to 5/8 of an inch. 0.625 is 5/8 of an inch. So minus 0.625. So for another 45 thousandths to that, I can get to a nice cardinal size. I'm like, right on. So from this side to this side is going to be 0.625, 5/8 of an inch. So I get a little over 100th thou on either side. Right on, man. So I'm looking fat, and I'm in some cardinal size, a nice round size, 5/8 of an inch. So now I've got the width of my part. For using that as a decider. Another decider I used is I turned the part 90 degrees, and I measured the web this way. And look at that, I'm coming around 5/8 again. So right on, I'm liking my 5/8. So my stock, my part, is going to be 5/8 by 5/8, rectangular, with this notch cut out on the top. Now what I have here is that 1/4 threaded spot at the bottom, so I can put, so I can interface with my existing bracket. So that's a simple part. That's just going to go in the middle. This other side, I'm going to radius the tops of these two flanges here, just like these are radiused. Because this part is going to fit inside of there, and it needs to swing in here and have clearance and not hit anything. And after studying this thing up close, if I can get the light to reflect off of it, down in this area, you can see some scratch marks. There's like a complete circular scratch in this area, and when it's interfaced with the parts GoPro makes, this included circle right here is 5/8 of an inch. So man, this is like freaking the golden the hill Dorothy in the Golden Road here. Everything is lining up. Wizard of Oz, jeez, couldn't find that for nothing. So we're following the yellow brick road, man. Everything's leading us right into Happysville. So this feature, I said that the width of my part from here to here, 0.625, and if I take an arc from one side completely to the other, that gives me a diameter of 0.625. But from the pivot point out, the radius to the edge, I need to take 0.625 and divide it by 2. And when I do that, when you take one of our Golden Road numbers here, yellow brick road, and divide it in half, it comes up with another beautiful number, 0.3125, which is 5/16. Right on. So I need a 5/16 radius tool to mill this. So I went digging through that box and was blessed to have a nice selection of the cardinal size radiuses, 5/8, 5/16, 3/8, half. So I was very happy that I could keep this standard. Standard means cheap. We don't need special tooling then. By the way, I'm smoking my first diesel uncut. What size is this critter? Bigger than 6. Yeah, so this guy's probably a 6-incher when we got it, and when I bought it. And the width is 0.81. 0.81. Don't know what it was supposed to be. But cigar diameters are measured in 64ths. So however many 60/4, this is to be the ring size. If it was 50 60/4, it'd be a .5. Anyhow, enough of that. It's a nice smoke though. So where am I at? Okay, so I know what all that needs to. Oh, the hole going through the middle. Great. I need to know what size that hole is going through this area. How big is that dude? Now what they do is they put a bolt through there, and then they tighten it up, and that's how it cinches it down. So I need to know what size bolt I'm supposed to use. So what I did here is I just went and grabbed some calibrated pins and put them in there until I found out what size it was. I came up with .199 inches. So I went looking for a .199 drill, and a .199 drill is a number 8 drill. There was one in my drawer, and it got me to thinking. I hate having special tools. I don't want to spend money I don't need to. Can I use something besides a number 8 that's not as extremely common for what my shop is outfitted for? And yes, the number 7 drill is a .201, so it's another 3 thou larger than that, but the number 7 is used to tap the drill holes for a 1/4 20 tap. So that's a common drill to have around. So boom, decision made. This hole is going to be .201. I know when I said this, I said max because that was the biggest pin that fit in that hole. Now, check this out. This is where I think I could have made a better decision. For example, here's my bolt. So I was living in the theoretical world. And in the theoretical world, the number 10 bolt that went in there, I don't have that number off the top of my head actually. A number 10 bolt has a major diameter, and theoretically and actually are two totally different things. The theoretical major of a fastener is not attained by the bolt nor the nut. They need to be, the bolt needs to be a little smaller and the nut needs to be a little bigger. So I was stuck in my theoretical world, and I found that this oversized hole is causing problems. Maybe I'll show you a little later when we get this thing mocked up. So now I've got the whole top of this thing figured out. The only other bit of data I needed to know how big to make the washer, how big. It's going to be a 5/8 inch washer. 5/8 inch diameter. Put the diameter sign in there. But the width, what width am I going to make that thing? So what I did is I took, once again, calibrated pins and slid them through this slit until I found out that the .135 fit the best. Now, in actuality, it could have been a .136, and if it was, I just would have naturally rounded it down to 5. Don't know if that's good or bad, but my brain loves round numbers and prime stuff. So, remember that. So, boom, I am now ready. I've got all my questions answered, the ones that I'm aware of at this point that I can answer. And I go into CAD, and I modeled up the part. Now, the nice thing that CAD does is CAD allows you to, I can make this part, I can make the other part, I can make several different parts, but then I can build an assembly with those parts, and then I can move them around and ensure that my assembly works. So that's why I'm a huge fan of prototyping in CAD. Do I have to have it? Nope. There were generations without it, but that's in the past. We are using technology now to do things as efficiently as possible. So I CAD'd it up, and basically what I get is I get this model over here. This looks like a solid because I have it grayed out, but on my print, what I did is I drug the bottom in as my primary surface, as my top surface. The primary surface, for some reason, typically wants to be top. This is not what I would call the top of my part, but I don't care. As long as everything does what I want, don't mind. So I drug this guy in, and then what that allowed me to do is reference everything from here. So I brought the bottom, and bottom's really simple. Bottom's going to be a 5/8 by 5/8. But damn it, that says 0.63, not 0.625. And you know what? Good catch. There's a 5 thousandths difference from that, isn't there? Here's the deal. When I dimensioned this and this, I just left it 2 decimal places. This outside diameter is nothing to be freaked out about. It can be plus or minus 100 thou for crying out loud. And this thing it's not going to affect functionality. Okay, not a big deal. So don't sweat it. Don't put tolerances in there you don't need. Now I did not fill out the tolerance block, but typically at 2 decimal places, 0.10 thousandths. And if I drag it out to 3, I'm having that, and I'm making somebody work harder to do something that is not necessary. So 2 decimal places. So I started with this guy, so it was simple. I put my 1/4 20 thread in it. That was another thing I had to decide too that we didn't discuss up here. I drew it on somewhere, didn't I? Oh, actually, I drew it on this page. Was the depth of these threads. I needed to decide how many threads I wanted and how deep the hole needed to be. So my number 7 drill bit, which is 0.201, needs to drill a hole. In this case, I made the math. I'm not going to bore you with it, but I went up here in my model and made sure it wasn't going to interfere. And the holes point a little over ½ an inch deep, and I only have 300 thou worth of threads. Now here's the thing about threading, is how many threads minimum can I have engaged, or do I want engaged? And once again, I only want to be, I'm shooting for minimum. Anything above minimum is going to be cake. So here's the deal. 3 threads is the minimum. So how deep do my threads need to be? I need to answer that question. To answer that question, it's a 1/4 20 bolt. 1/4 inch means that's my major diameter. The -20 means how many threads per inch. Oh, cool, a rate. I know what to do with a rate. A rate's nothing but a fraction. That dude is 1 inch divided by 20. So, just by breaking this down and telling me, dividing 1 by 20, I know that 1 thread is going to travel 50 thousandths. Cool, I want 3 threads. So I took 50 thousandths times 3 and came out with 150 thousandths. So that's the minimum I need. Now, because I'm an engineer, I'm going to double it for safety. So boom, I'll come up with 300 thousandths. Okay, cool. So my threads are going to be 300 thou. How deep is my hole going to be? Okay, which now, the end of my tap does not cut. I need to make room for the tip of this blunt motherfucker to get in there and do its business. So you need to measure your tap and figure out how much deeper your hole needs to be than your threads are to make room for it. So I added 150, and it came to 0.45, and I went a little bit fatter because breaking taps down inside of a bore is kind of something I've been good at. So I made the hole a little bit deeper. So boom, there's that decision for that 1/4 20. Everything else here is marked out pretty good. So I did the next natural thing for me now is I took this model and I clicked on another tab in SolidWorks called CAM, and I started using HSMWorks to put tool paths on this solid. Now, following Tom's logic, I jumped into CAM before I should have. Alright? And it was another step. Tom didn't address this specifically, but it's the same principle. What I did is I spent the next half hour to 45 minutes putting tool paths on this part and struggling with work holding and which way I'm going to do it and how much, what size my stock would need to be to do it in certain ways. And after that while, I'm like, what am I doing? If I was to do this on the manual mill, how long would it take me? And you know what? It's like, I would have been done by now. So boom, I jumped off the computer, jumped on the manual mill, and whipped this sucker out. So here's the part. It does not look like the print. Most of it does. I mean, I couldn't sell this to a customer. The reason being is I arbitrarily, not so much, but I decided my overall height of the part needed to be 1 1/8 inches. So that's, once again, that was my minimum. And since 1 1/2 inches, once I put it in my hand, I thought it was a little small. I added a little more to it. So what do we have? overall part's 2 inches. So I arbitrarily changed that to 2 inches. In this case, no biggie. Shoot, in actuality, I should go down to 1 decimal point. Anyhow, I don't do my prints. I don't do machine prints down to 1 decimal. The only thing that I would take to 1 decimal place would be the piece of stock I'm cutting on the bandsaw. But that's neither here nor there. So there's the part. And here's the washer that's going to go between them. So the way you assemble this, guys, you take this washer. Oh, by the way, the washer is off center. I am rather embarrassed. That hole is not in the middle. It was a foolish mistake. I knew better, and I did not go. For some reason, I was in a rush to get this done. I honestly don't know why. Boom. So there's the washer. The washer's in there. Now, let's put this guy on. If you notice, I'm not fighting anything. I did all my fits. Okay, now I need a piece of hardware to go through this thing. And I need a nut to tighten it down with. So, do I want to use wrenches to tighten this thing down? No. So, Mr. Wing Nut is the answer. That's how I'm going to tighten it with this wing nut. So, let's put the bolt in and put the wing nut on. And the first thing I noticed was my wing nut hit the housing. I couldn't turn it. So, I was like, damn, a wing nut won't work. I got to use a wrench. And once again, I jumped the ball too quickly. What I did is I got a longer bolt, put a spacer on there, and moved that wing nut out of the way. Now, if it were me, GoPro, which you're never going to watch, I would just make this, these ears on the housing 1 inch instead of 5/8 on center, or overall, and you would clear up the need for this ridiculousness here and be able to put a fastener underneath the housing. Anyhow, so there we go. And that's how I came about engineering this lovely, oh, by the way, this is too long. This head carriage bolt is not what I would care to use, but it came out of my junk drawer. That invaluable box of crap that I have. So, that's how I did it. And I want to thank Tom for his help in helping me see the light.